Okay, how did you make out with these? First one's pretty easy. Isolate the x squared so that you can isolate the x by taking the square root of each side. So I see that x equals plus or minus square root of 20. 4 is a perfect square that divides 20. So I break it into this product here. Square root of 4 is the same as 2. There's my answer in simplified form. Over here, I've already got the squared expression alone, so my first step is take the square root of each side. So I get 2x plus 1 equals plus or minus square root of 20. Square root of 20, we did that in the last problem. Let's use our work. Go right to there. Subtract 1 from each side. Divide each side by 2. And I can simplify this thing. If I break it into two fractions, I get x equals negative 1/2 plus or minus 2 times square root of 5 over 2. And the 2's cancel out. So I'm left with this. There's my finished product. All right. Now, let's look at a really painful technique that students really don't like. We'll see it. You'll probably never want to use it. If you want to use it, be my guest. But the other methods are easier. The one reason why I want to show it to you, though, and the reason why it's in your textbook, is because you'll see it used from time to time. You'll be reading something in your algebra book or in a calculus book in the future, and they'll use this technique, which is called completing the square. So this is our third major method for solving any quadratic equation. Now, factoring does not always work. Not every quadratic is factorable. Let's look at example 7. Page 188. You can try to use that method that we've been using to factor this, and you'll soon figure out that no combination can possibly work. This cannot be factored using integers. I have to put using integers in there because it could be factored using messier numbers, but nobody works like that. All right, there's a whole nother technique. Instead of having the 0 on one side, let's mess it up and put the constant on that side. The reverse of what we did before. Since I have x appearing in both terms here, I can factor x out. Oh, I didn't want to do that. I could factor x out, but instead I want to complete the square. Almost forgot what I was doing. What would have to go in there to make this a perfect square? When I say make it a perfect square, you know, make it look like a binomial squared. $36. Right? Then it factors like that. Of course, I can't just go ahead and add 36 to one side and be happy. Whatever you do to one side, you have to do to the other. So I have arrived there. And now it looks like one of your square root problems, taking the square of each side, taking the square root of each side. There, I take the square root of each side, and of course my next step is going to be isolate the x by adding the 6 to each side. Oops. There's my solution. Now, whenever a quadratic will not factor over the integers, as I mentioned 2 minutes ago, you're always going to end up with that radical sign in the answer. That's the special logic going on in the background. All right. Was that painful enough? Probably, because algebra students just don't like to use that method. They would assume that you could just erase it out of your mind just like this. And guess what? You are not required to use that method. In fact, for the problems that we'll be solving from this section 3.2, I will let you have your choice of methods. If you can leave this course knowing how to solve it by any method without me telling you which method you have to use, I would be very happy. However, we're still stuck with this situation. There are some quadratic equations, in fact the great majority, that will not work, will not be solved by factoring. This method works all the time, and it's not as painful as what we just looked at. It's not great, but it's not as painful. There's a magic formula. That solves every quadratic equation. X equals minus b plus or minus the square root of the quantity b squared minus 4ac all over 2a, where a, b, and c are your coefficients of a quadratic in standard form, as we've seen many times. Oh, well, what do we do with this? We do example 8. First thing we want to do is get this into standard form. Right? Now I see that A is -3, B is 4, C is 6. You're done. You're just going to plug it right in. B is 4, so I have -4 plus or minus the square root of the quantity b squared. So that's 4 squared minus 4 times A. A is -3 times C. C is 6 over 2 times A. Couldn't be easier, right? I'll always provide this formula to you on the test. You don't have to memorize this big messy formula. All you have to do is just plug the numbers in. As soon as you make sure you've know which one is which. Get it in the right order if you have to. Alright, so we do a whole bunch of calculations over here. Minus 4 plus or minus the square root of 16 plus 72 over negative 6, which equals negative 4 plus or minus the square root of 88 over negative 6. Now you see it's a little more painful because you're always going to have the square root hanging around because it wouldn't factor over integers. And you always have the plus or minus sign there. Now in this case we got a minus sign in the denominator. That's never acceptable. Minus sign over there. Divide top and bottom by negative 1 to get rid of the minus signs. You say, yeah, but what about the plus or minus sign? It's still the same two possibilities. You could write it as a minus over a plus if you felt like it, but dividing this by negative 1 doesn't create any more possibilities. So we end up with 4 plus or minus square root of 88. Does anybody see a perfect square that divides 88? Yeah. 4. Okay. Get a little more space here. So I get 4 plus or minus 2, right? The square root of 4 is going to give me a 2 times the square root of 22. Square root of 22 can't be simplified any further. There's no perfect square that divides 22 except for 1, and that doesn't help us. Finally, even number, even number, even number. Divide everything by 2, that just goes away there. And we get the answer that's shown in your book. 2 plus or minus square root of 22 all over 3. Any questions? I don't hear anybody asking a question, so you must all be ready to solve one of these. Go ahead and do this one. X squared minus 2x minus 4 equals 0. It will not factor over the integers. So you could use completing the square if you feel like it, or you can use the quadratic formula. I'll leave it up to you, and we'll be back in a moment to see how you made out.